through and explain free response number 3 from the 2008 AP Chemistry exam. So for A, to begin with, it tells you that you have that reaction, okay? And it says, using the information above and in the table below, calculate the standard reduction potential for the reduction of NO3 minus in acidic solution. So the hardest part about this question is realizing I've got two half reactions. I'm going to add them together to get my whole reaction, but what it's actually asking me for is the reduction potential for one of my half reactions. So what I need to do is manipulate my two half reactions to figure out how I can add them together to get that final reaction. So if you look, I need to take that first reduction potential for copper, I need to flip it so that solid copper is a reactant, and I need to multiply it by 3. For the NO3 minus half reaction, I don't need to flip it, I just need to multiply everything by 2. So those two reactions added together will give me that overall reaction up above, which has a cell potential of positive 0.62 volts. Now the one thing for you to keep in mind, while I am multiplying the copper by 3 and the nitrate by 2, you don't multiply your cell potentials by that value. You only multiply it by -1 if you flip it. So ultimately what I get when I add these two reactions together, when I add their cell potentials, it would be -0.34 volts plus X, because I'm trying to solve for the nitrate, equals positive 0.62 volts. And so the answer you end up getting for the reduction of nitrate is going to be 0.96 volts. So you get 1 point for the correct answer. Please make sure to be careful with units because they might take off, and that's a silly reason to lose points. For B, it says calculate the value of the standard free energy change for the overall reaction. Well, I'm going to use the fact that Gibbs free energy equals negative NFE, negative number of moles of electrons, Faraday's constant times the cell potential. Keep in mind that this is 6, so this is where a lot of people mess up. So if we go back, keep in mind I multiplied my copper half reaction by 3, my nitrate by 2, so the total number of electrons that are being transferred are actually 6. So it's going to be 6 times Faraday's constant, which I put as 96,485, but they rounded it, times the cell potential you got in A, and then you get your answer in joules per mole. Okay, you can leave it in joules per mole, or you can convert it to kilojoules per mole. It doesn't matter. Keep in mind here, because it's asking for the overall reaction, don't be tricked and plug in your answer for A here. You need to plug in the overall cell potential, which is 0.62 volts. Okay? In C, it says predict whether the value, so you got 2 points total for that question. Predict whether the value of the standard entropy change for the overall reaction is greater than 0, less than 0, or equal to 0. So if I look at this, okay, I've got 3 moles of solid, 2 moles of aqueous solution, or 10 moles of aqueous solution on my reactant side. And then I have 3 moles of aqueous, 2 moles of gas, and 4 moles of liquid, which tells me that my delta S is going to be positive because I'm producing 2 moles of gas. So while it talks about different numbers of ions and everything, the most important thing here is that you're producing a gas, which is going to cause your delta S to be greater than 0. Okay, so making sure to highlight the point that you're creating a gas, which is going to cause more disorder. So you get 1 point for the correct answer with the justification. For the next question, it tells you nitrogen monoxide gas, a product of the reaction above, can react with oxygen to produce nitrogen dioxide as represented below. So now I'm dealing with a totally different problem now, right? It's having me move on from what I was doing before. So here we go. Okay, it asks me in D, determine the order of the reaction with respect to each of the following reactants. So NO versus O2. So if you go back, my explanation, for example, for O2 would be between experiment 1 and 2, the concentration of oxygen triples, okay, while the rate also triples, which means that it's going to be first order. Now remember, just as a review, remember if you're wanting to get rid of the times 10 to the negative second or 10 to the negative first, you're going to multiply by 10 to the second, so that becomes 8.52. You multiply the other two by 10 to the second, so that becomes 25.6 and 76.7. It's a little bit less necessary for this because you can use your calculator to determine it, but if you were doing multiple choice, you could still do it by multiplying by 10 to the second. So it's first order for O2, okay, and then I would look between trial 1 and 3. Between trial 1 and 3, the concentration of NO triples, while the rate increases by a factor of 9. Therefore, it's going to be second order for NO. So making sure that you're talking about it tripling for concentration and increasing by a factor of 9 for rate, just making sure your terminology is clear. If you got each of those, then you got 1 point for each of them. And so your expression is going to be rate equals K times your concentration of NO squared times your concentration of O2. So you get 1 point for that. Okay, so this problem so far really has not been that tricky. Please do not be losing points for fairly easy questions by skipping details and therefore not getting the points necessary. Okay, for F, determine the value of the rate constant for the reaction, clearly indicating the units. Okay, so this problem was a little bit funky because if you notice the rate, if we go back, the rate is for the formation of NO2. And so when we've been doing these problems before, we're assuming we're talking about the overall rate of the reaction. But notice, because there's a 2 in front of NO2, you should actually take whichever initial rate you want to use for NO2 and divide it by 2. Now, they didn't take off if you forgot to do that. And it says here, a rate constant of that earns a point if the rate of reaction is assumed to be the same as the rate of formation of NO2. And I'm assuming they did that because so many people missed it. So don't worry about it if you forgot, but just in the future, when you look at what it's saying the rate of, and make sure that if you have a coefficient to divide by that value. But even if you didn't do that, remember it's rate equals K times NO squared times O2, and so you can simply solve this even if you didn't divide by the half, otherwise you should have gotten this. So either gotten 3.55 times 10 to the third or 7.10 times 10 to the third. They write it with moles and liters. I would have just said molar to the -2, seconds to the -1. Now the reason why it's molar to the -2, seconds to the -1, remember, first of all, if we look back at my rate, it's molar per second, and since it's overall third order, in order to get rid of the molar cubed and just to make it molar, I need to multiply by molar to the -2, seconds to the -1. So they love asking this question. Notice they gave 2 points, 1 for the correct answer and 1 entire point for just the units. So even if you got this entire thing wrong and put the correct units based on your rate law, you would have gotten a point. So please do not lose points for your rate constant units.